Hi everyone, I am Dr. Sagar Saab and welcome to Vet Surgery Teach. So today we will be starting the inhalant anesthetics. The inhalant anesthetics will be covered in 3 classes. First class will be for breathing circuit. Second class will be the anesthetic machine. Third class will be details about the anesthetics, both the volatile and the gaseous. Okay, so before going to the class, you should know that in India, most of the colleges are still dependent on the injectable anesthetics. Okay, so you will find very few colleges where the anesthetic machine has been installed and regularly used. In many colleges, you will find the machine is installed, but they are not used regularly. So you will find the concepts of inhalant anesthetic lacking, or you can say there are many colleges where these topics are not touched. But here we will touch every topic. I will tell you an interesting story why I started also this channel. Okay, there is an interesting story. It is related to inhalant anesthetics. You see, in the inhalant anesthetic, we are still in nascent stage. Okay, because all the colleges are not using this inhalant anesthetic. Okay, so it may take a decade for proper use of this inhalant anesthetic machine in veterinary science. But before that, you should be prepared for all the you should prepare with the concepts. Okay, so today we will be studying the breathing circuit. You see, this is a inhalant anesthetic machine. This is a machine, this is a machine. These are two machines. One is for isoflurane. You see here, the purple color is isoflurane and the yellow color is sevoflurane. Okay, remember the color coding. Sometimes they are asked in the exam. Yellow for sevoflurane and the purple for the isoflurane. These two volatile anesthetics are commonly used in veterinary anesthesiology. Okay, so the machine has two parts. The machine itself, this is the machine itself, which provides the fresh gas flow. Okay, what is fresh gas flow? We will be discussing later. And this one is the breathing circuit. Breathing circuit. This breathing circuit acts as an interface between the machine and the patient. Okay, so we will be discussing this breathing circuit in this class. Let us go to the breathing circuit. The classification of breathing circuit. You see, this is a there are two classifications we will be discussing. Based on different anesthesiologists, you will find different classification, but they are more or less same. Okay, breathing system can be classified as open, semi-open, semi-closed and closed. You will find this classification in your book, especially in the pharmacology book. Okay, so the open system, in which you simply soak a gauze with inhaled anesthetic and keep it close to the dog's nose or cat's nose, whatever the animal, and it will breathe some vapor or the ambient air. The ambient, no rebreathing, there will not be any rebreathing. Ambient air will act as fresh gas flow. Okay, ambient air will come and it will come in contact with the anesthetics, and with the air the anesthetic will go into the nose. Okay, so this is open system, and when patient will exhale, it will go into the atmosphere. Okay, so there will not be any rebreathing, and both open and semi-open. You know what is in semi-open? Simply it is a modified version of this one. There will be a mask. Suppose imagine a N95 mask is installed to your patient's nose, or you can say dog's nose, and in the inner side there is anesthetic. So when the ambient air will come in contact with the inhaled anesthetic, it will take the inhaled anesthetic into the nose, and when the patient will exhale, it will go to the atmosphere. There won't be any rebreathing. Okay, so remember, the ambient air here acts as the fresh gas flow. Okay, fresh gas flow. These two are very important. The semi-closed and closed system. This is not used neither in human or nor in. This is used for kidnapping. In movies you will find use of this one for kidnapping. But in practical or anesthesiology point of view, these two systems are very important, and watch carefully. First one is semi-closed system. The example of semi-closed system will be the Mapleson system. We will detail study about the Mapleson system or Mapleson circuits. In closed system, the circle system. These two will study in detail. One thing here in Mapleson system, you will find partial rebreathing, but some anesthesiologists may consider this as non-rebreathing circuit, and the circle system as rebreathing circuit, because here there will be complete rebreathing of gases. This is rebreathing circuit and this is non-rebreathing. But in practical sense or actual sense, there will find partial rebreathing and the complete rebreathing. Okay. Here the anesthetic machine, which I told you, acts as fresh gas flow. The fresh gas flow can be purely oxygen, or it can be admixture of oxygen and anesthetics. Anesthetics means it may be volatile, which is basically isoflurane and sevoflurane, or it can be gaseous, that is nitrogen oxide. Okay, we will deal with the anesthetics in the third class. Now, let us come to another classification. Some anesthesiologists classify on the basis of carbon dioxide absorption. Without the carbon dioxide absorption, the Mapleson system is the best example, and also Ambu bag, and the system which have the carbon dioxide absorbent, they are known as the circle system, or the example is the circle system. Mapleson system is of 6 types: A, B, C, D, E, F. A, B, C, D, these 4 are for adult patients. E, F is for pediatric. You see, these are classifications based on human anesthesiology. Okay, but you should know this. There are some other names of these systems. Mapleson A is known as Magill's circuit. Magill's circuit. This A has a modification known as lac modification. Okay, B and C are basically useless. They are not used anywhere. D doesn't have any other name, but it has a modification known as Bain's modification or Bain's circuit. This is modification. Okay, and the interesting story lies with the Bain circuit. Once upon a time, I went for a assistant professor interview. Okay, so the interviewer asked, "Have you ever seen inhalant anesthetic machine?" Yes, sir, because there was a machine in my college. Okay, but you see, I was not taught everything about inhalant anesthetic. I was only taught about the anesthetic agent. So I knew the anesthetic agents, but I did not knew what are the breathing systems, what are the circuits, and how machine operates. Okay, so when he asked this Bain circuit, I couldn't answer because I didn't know. Okay, so this is the story, and that actually led to the foundation of this channel. Okay, so Mapleson E is IR's T-piece. This is also known as IR's T-piece. Mapleson EF is for pediatric patient, ABCD is for adult patient. F has a modification actually, which is known as Jackson-Rees modification. Okay, so these are Mapleson systems. We'll study about Mapleson A, Mapleson D. Okay, because they are adult circuits and they have very importance in anesthesiology. Okay, A and D will be studying, and with this CO2 absorption, I told you example is circle system. We will also study about the circle system. So in this class, we will be studying the A, that is Magill's circuit, Mapleson D, and the circle system. These 3 we will be studying. Before going to the circuits, we should know what are the components of a breathing circuit. The first component is reservoir bag. This one is reservoir bag, or you can say rebreathing bag. This reservoir bag has multiple functions. One among them is it helps in peak inspiratory flow, as it contains both expired and inspired air. So it helps in maintaining the inspiration flow. Okay, if it will not be there in the circuit, you see, for inspiration flow you need higher fresh gas amount. Okay, so this helps in peak inspiratory flow. Second, it also acts as a pressure buffer. Okay, it maintains the pressure of breathing circuit. It also acts as pressure buffer, and also you can monitor the respiration rate by looking at this reservoir bag. Okay, and fourth, it also helps in controlled or assisted ventilation. Controlled or assisted ventilation. What is this one? Suppose your patient is not breathing, you need a controlled flow or controlled breathing. So you can close this. I will talk about the APL valve. You will close this APL valve by squeezing this reservoir bag. You can provide air to the lungs of the patient or provide the gas into the lungs of patient. That is why this is controlled or assisted ventilation. Okay, this is reservoir bag. The next component is APL valve. This one is APL valve, adjustable pressure limiting valve. Okay, the other name of APL valve is spill valve. Okay, so this valve, one thing you should remember about this valve is when in controlled ventilation, I just told you about the controlled ventilation, it should be remain off. It should remain off or closed. During spontaneous ventilation, this is spontaneous ventilation means patient is breathing on its own. In controlled ventilation, you are providing the breathing. Okay, you are providing the gas or you are helping the animal to breathe. Okay, in spontaneous breathing, it should remain open. Okay, it should remain open or on. Okay, this is APL valve. You know about the reservoir bag and APL valve. These two are very, very important. Next is tubing. You see, this is tubing. Earlier, a simple tube was coming, plain tube. The problem with this plain tube was when it was bent, there was kinking. Okay, so nowadays this corrugated type of tubing is coming, corrugated, so that when you will bend them, you see here it has been bent, so that there won't be any kinking. Okay, so this is tubing. Next component is this one. You see this jar here and also this jar here, you can say this is CO2 absorber. Here we will find there are many agents which are used for CO2 absorption, just like soda lime, baralime, calcium hydroxide lime, and there are also some more. But the soda lime, this soda lime is the most common one. The composition of soda lime is, remember, calcium, sodium, potassium, all are in hydroxide form. Calcium hydroxide, sodium hydroxide, potassium hydroxide along with H2O. Okay, this is the composition of soda lime. In the soda lime, two things are added for preventing the dust formation. They are usually asked. The things which are added here, coaxial and silica. These two things are added to this soda lime so that there will not be any dust formation. Okay, so when you will know that it is time that you should change this soda lime, because after certain time or certain period, this there will be the capacity of this soda lime will not be there to absorb further CO2. You see, usually you will find color indicators. But these color indicators are usually not reliable. Okay, the reliable one is CO2 inspiratory CO2 concentration. You see, there will be monitors, okay, which will be measuring this CO2 concentration. So when the inspiratory CO2 concentration will be increasing, you will know that this soda lime is not working because it is not absorbing. We will discuss this soda lime, how this soda lime works, how the expiration goes, and how this CO2 is absorbed. We will discuss all the circuits also. There we will know that if this is not functioning, this particular thing is not functioning, then in the inspiratory limb, you see, one thing I forgot to mention, this tubing, it has two parts. This one is inspiratory limb, and here this one is expiratory limb, okay, through which here the gas will go and here the exhaled gas will go. Okay, between these two there will be CO2 canister, or you can say this soda lime. Okay, the gas will come here and the gas will go to the machine here. Here, when it will be again rebreathed, there this soda lime canister will be there. So here this reabsorption process will there. Okay, if this one is saturated or it has no capacity to inhale or absorb the CO2, then what will happen? The CO2 concentration in this inspiratory limb will increase and it will be shown in this monitor. From that you will know that it is time to change this soda lime. Okay, so fresh soda lime will be filled in that canister. Okay, so you understood the parts. There is another one part, this Y piece. Okay, here it is very clear. You see this Y piece. Okay, Y piece. Another important one is unidirectional valves. This is very important for circle system, not in Mapleson system but in circle system. You see here this in the inspiratory limb and the expiratory limb. Here you can see here you will find the valves. These valves does not allow the to and fro motion of the gases. In the circle system you will see where the unidirectional valves are placed, how they work. Okay, so unidirectional valve. These are the components of this breathing system. Here you can see a thing. You see this one. In many movies or many series, you may find this thing which usually goes up, comes down. This is known as bellows. Bellows can be two types: the ascending one and the descending one. How will know that it is ascending one or the descending one? Bellows are part of ventilatory system. Okay, in many of the modern anesthetic machine, there is another system installed for the ventilation, that is ventilation system. Here there will be switch. You either can use this rebreathing bag or you can use this ventilation system or bellows. There will be a switch, venti bag switch. Okay, VV switch. Either you want to use ventilation or the bellows, or you can use the bag. This one rebreathing bag. So how you will know whether this is ascending or descending? When the animal will expire, on expiration, if you can see this one, if this goes up, then this is ascending one. Simply if you look, take it to the below hand, it will become the descending one. On expiration, if you are going up, then it is ascending. If it is going down, then it is descending bellows. You will not much discuss about this bellows. Okay, we will mostly discuss about the circuits. Now you have understood all the components. Another revision. This one is reservoir bag. This one is APL valve. Okay, in APL valve you will find a spring system. When there will be high pressure build up in this breathing circuit, it will open up automatically and the air will go out and the pressure will decrease. So first one reservoir bag, 2 the APL valve, 3 is the tubing. These are tubing, fourth eyepiece, and fifth the soda lime canister or CO2 absorbent. Okay, so these are part of the breathing system. Now we will go to the actual breathing system or the Mapleson system. See, this is Mapleson system. Mapleson system comes under non-rebreathing circuits. Okay, I told you there will be partial rebreathing, but it mostly comes under non-rebreathing circuit. Here Mapleson A, B, C, D, E, F. I already told you A, B, C, D are adult circuits. E and F, they are pediatric circuits. Okay. One more thing we will be discussing, you know, A and D. There is a if someone asks you that if you will arrange this A, B, C, D, whether they can be used for spontaneous ventilation or the controlled ventilation. If you are using for spontaneous ventilation, if you have to choose from the best to worst, for spontaneous ventilation, remember, all dogs can bark. All dogs can bark. Best will be A. The worst will be B. For controlled ventilation, or you can say assisted ventilation, when providing some assistance to the ventilation or breathing of the animal, for that dead bodies cannot argue. DBCA. Okay, dead bodies cannot argue. The best one is D. So if someone asks among the Mapleson system which one is the best for spontaneous ventilation, answer will be A. If someone asks the which one is the best for the controlled or assisted ventilation, the answer will be Mapleson D. So we will be studying the A and D. Okay, so remember this one, all dogs can bark and dead bodies cannot argue. E and F basically the pediatrics. I told about Mapleson E, this is also known as Ayers TPs. There is nothing here, the press gas flow, and here there is patient connection, and here is press gas flow. So it looks like a T piece, so Ayers T piece. Okay, and this Mapleson F, I told you this is a modified version. This is known as Jackson re-modification or Jackson-Rees modification, where they have added a reservoir bag, so that if you want a controlled ventilation to babies, you can simply press this one for controlled ventilation. You can put your thumb here and you can simply press this or squeeze this one. You will find some assisted ventilation to the babies. So now we will study the Mapleson A and the Mapleson D. The Mapleson A. So the pictorial presentation, here the press gas flow will go. This is the reservoir bag. You see, this is inspiration line. Okay, the gas is going to the patient. There isn't any expiratory line. In the original configuration, there isn't any expiratory line. How the gas will flow? Here the gas will flow towards the patient. Some will be collected in the reservoir bag. Here it will go to the patient, and when the patient will expire, it will go through the APL valve. Some will come to the reservoir bag also. Okay, so partial rebreathing, and there isn't any expiratory link. So a scientist named Lack thought that why not we provide a expiratory link. You see, problem here, APL valve is a controlled mechanism, or you can say this is a control through which the breathing circuit can be controlled. This is patient's end and this is the machine end. Okay, here one control mechanism is towards the patient end. Usually anesthesiologist sits towards the machine end. Okay, this anesthesiologist will be sitting at the machine end. So if he or she wants to close this APL valve, or you can say he or she wants some assisted ventilation, so he or she has to get up towards the patient side and do the needful. So this scientist Lack thought, let us solve this problem. So he actually suggested this is a coaxial configuration. Coaxial means tube within a tube. So he suggested a coaxial modification. What he did, he provided an expiratory limb. This is an expiratory limb, or you can say he provided a passage so that this APL valve can be placed at the machine end. Okay, so that the anesthesiologist doesn't have to get up and go to the patient end for the control. Okay, it is placed in machine end. So now what will happen? Through the outer tube, the fresh gas will go towards the patient. When the patient will exhale, through this inner tube, the gas will go out. Some will also enter the outer tube and come to the rebreathing bag. Okay, understood? Here see, this is a parallel setup. Okay, here through which the gas will go towards the patient, and patient will exhale, it will come out through this one. Okay, simply in this setup, the tube is simply outside. Okay, this is coaxial configuration and this is parallel configuration. You see the difference between Mapleson and A and D is, see here the reservoir bag is in the inspiratory limb. I will discuss the Mapleson D, this reservoir bag will be in expiratory limb. Okay, this is a difference between Mapleson A and D. So you understood what is Mapleson A. Mapleson A is best for spontaneous ventilation because the fresh gas flow needed is equal to the minute ventilation. This is the most of the data is from human anesthesiology, but in veterinary anesthesiology book you will also find of these mentions. Okay. Next, the Mapleson D system. Mapleson D. In this Mapleson D, the fresh gas flow is at the patient end. Okay. So here there will be machine and the anesthesiology will be sitting here. Okay. So fresh gas will come through here and will go to the patient. When the patient will exhale, it will come to the APL, go through the APL valve. Some will be into the reservoir bag. Here the same problem. The control or the machine is near the patient end, which is very difficult. Okay, for the managing things. So what a scientist named Bain, he modified this circuit. Here you see there isn't any inspiratory limb. There isn't any inspiratory limb. Here only the expiratory limb is there. Okay, this is expiratory limb. So what he did, let us provide a inspiratory limb, or provide, sorry, an inspiratory limb. So what he did, he simply, just like the other one, the lat modification on Mapleson A, he provided a inspiratory limb. Okay, this is coaxial configuration. Bain circuit doesn't have a parallel configuration. It has a coaxial configuration. That is tube within tube. Coaxial configuration. The fresh gas flow will come through the inner tube or go through the inner tube towards the patient. When the patient will exhale, it will come through the outer tube and it will be expired out, or it will go, some will go to the reservoir bag. See here, okay, you can see the green one, inside one is the inspiratory limb through which the fresh gas flow will go, and through this outer limb, or you can say outer tube, it will go out, or some will go to the rebreathing bag. Okay, now you have understood. Here I told you Mapleson, in Mapleson D, the bag is in expiratory limb. Okay, this is a difference between the Mapleson A and D. Also the APL valve. There APL valve was at the patient end. Here the APL valve is towards the machine end. Okay. So, and another advantage of this one is, you see, you are providing the fresh gas flow to inner tube. So the exhalation or exhalation gas is coming through the outer tube. Usually the exhalation gas are at the normal body temperature. So if at all this fresh gas flow has low temperature, then there will be temperature exchange and it can warm up this fresh gas flow. Okay, this is the advantage of Bain's modification. Okay, when I ever take Bain's name, I like, oh my god, if I would have answered this one in my interview, then interview would have been different. Okay, anyway, so this is Bain's modification. Okay, the Mapleson, so we have studied Mapleson A and Mapleson D. I hope you have understood what the circuits are. Okay, now coming to the circle system, which is basically very common nowadays. You will find this circle system in all veterinary anesthesiology use. Okay, so this is circle system which was designed in 1926. Here understood. This is fresh gas flow. When the fresh gas flow will go, here you see the unidirectional valve. Okay, it prevents any expiration gas coming into the circuit. Okay, sometimes placed here or here, whatever this function is same. So it will move through this inspiratory unidirectional valve, and it will go like this into the patient. When the patient will exhale, some will go through this limb, inspiratory limb, but it cannot go further because of the presence of this unidirectional valve. So it will go to the expiratory limb and it will move through the expiratory unidirectional valve. Okay, you see, when the fresh gas is flows, you will see some gas will also come this way. Okay, so this unidirectional valve will prevent this flow. Okay, so this is the importance of unidirectional valves. Okay, so now what happens? Through the expiratory limb, it will flow through the expiratory unidirectional valve and it will go to the reservoir bag. If there is high pressure or some problem, it will go through the APL valve, and some will go to this canister. This is CO2 absorber. Okay, here there will be soda lime. Now you understood that configuration. Here I will tell what happens. Okay, soda lime here, and so the carbon dioxide present. In expiratory limb you will find carbon dioxide. So this carbon dioxide will be absorbed, and other gases with some, there will be some inhalant anesthetic also, they can be rebreathed or reused. That is why you will find this known as rebreathing system. Circle system also known as rebreathing system. Okay, so there will be rebreathing of gas. Due to this rebreathing of gas, the fresh gas requirement is very less compared to the Mapleson system. In Mapleson system, you may find higher need of fresh gas, while in case of circle system, you may find low need of this fresh gas. Because of this use of exhalation gas through which the CO2 is separated, and rest gases can again be used for this breathing. Okay, one thing here, the bellows. Okay, I told you can either use this reservoir or you can use bellows. Here you will find a switch. Okay, the bag venti switch or baby switch. Okay, here switch, and you will find the addition. Sorry, I can. So here there will be bellows. Okay, bellows has a different mechanism. If I will get time, or you can say there will be demand, I can show you how bellows work. Okay, so here the BV switch will be there. You can either use the bag, or you can say reservoir, or you can say ventilator, or the bellows. Okay, bellows, I told you, on the ascending and descending time, there is also mechanical ventilators, piston style. Okay, there are many types of ventilators are also there. They have a very different configuration than this one. They have their own gas inflow circuit, like that. They have very different things, but for basics you should know that here you will find a switch. In many anesthetics, here you will find a switch. There is a switch here through which you can switch into the either the bag or the bellows, or the ventilation system. And from the APL valve you will find a tube coming out, which goes to scavenging system, which scavenges the inhalant anesthetics. Inhalant anesthetic. Why this is necessary? Okay, here the machine you may not find, the tube is not being shown. but there will be a tube which will go to the scavenging system. Why it is necessary? You see, when the patient will exhale, it will not only carry the carbon dioxide, also some inhalant anesthetics. So the inhalant anesthetic will come here, and through the APL valve it will go to the atmosphere. For long duration of surgery, when the surgery is for more than, you can say, very long time, 5 hours, 6 hours, 7 hours surgeries, the inhalant anesthetic will build up inside the room. Okay, so you can say this can hamper a surgeon, or surgeon can inhale those anesthetics and can be sedated. So to prevent that, there will be another tube from this APL. You see, through this APL valve only it is going to the atmosphere, or you can say inside the operating room. So if you have provided another tube through here to the scavenging system, which will scavenge this inhalant anesthetic, so it can prevent the building of inhalant anesthetic inside the operating room. Okay, so now you know what are the parts of this circle system. Okay, let me wipe this one so you can see another time. Okay, so here the fresh gas will come, it will go through the inspiratory unidirectional valve, and then it will go to the Y piece, and through Y piece it will go to the patient. When the patient will exhale, it will contain carbon dioxide. It will go through the expiratory limb and then expiratory unidirectional valve. Then it will go, some part will go to the reservoir bag, and if there will be excess pressure, it will go to the atmosphere to the APL valve, and some part will go to this carbon dioxide absorber, where the carbon dioxide part will be absorbed and the gas can be reused, or it will again be into the inspiratory limb. Okay, so this is circle system. So let us understand the circuit in this machine picture. Okay, this machine will provide the fresh gas flow, FGF. Okay, we will discuss about this machine in the next class. Through this inspiratory limb, the gas will go. Okay, it will go to the patient. From the patient, the exhaled gas will come and it will go through this expiratory limb, okay, into this thing. You see, it is a box type design. There will be the tubing. Okay, when it will go, some will go to the rebreathing bag and some will go through the APL valve, and most of them will go through this canister here, which is soda lime canister, and it will again come back to the inspiratory limb. Okay, so this is machine. You see here that is little, there will be inside tubings. Okay, I cannot show you in the outside, but the concept is like this. Okay, so now you know the circle system, how they work. Okay, next class we will go for the machine. What are these things? What are the flow meters? How the sevoflurane vaporizer works? Okay, all those things. What is oxygen flush button? What is flow rate? Okay, all those things we'll be discussing in the next class regarding the anesthesia machine. And this is all about today. I hope you understood all the circle systems and the Mapleson system, and I hope if this comes as a long type question in examination regarding the breathing system, I hope now you can write them very well. So we'll meet in the next class. We'll study the anesthetic machine. Till then, tata, bye bye, take care.